And now we're on to solutions. So the first thing they're looking at here is called the solution process. So the solution process here, if we're looking at this, is just showing us literally, how do solutions form and how does that kind of deal with that. So when we're talking about a solution, you just want to keep in mind that we're talking about a homogeneous mixture. So remember, we typically think of solutions as, liquids. But they can be gases, then they can be solids. And again, it's just a single phase. So the three attributes that we want to make sure we are aware of is they're going to be uniform throughout. They're not going to settle out if we just let them sit there. And there is still a subdivision. They're not bonded together chemically. The fourth thing is that there is no Tyndall effect. So Tyndall effect is a scattering of light. And this is typically due to colloids. And for example, like if the reason why your headlights don't work well in the fog is because the fog is very good at basically like scattering the light thing. It also happens with milk. It also can happen with some jello, thick jello, that kind of stuff. So those would not be considered solutions because they're more colloidal. There's two parts that we have here. So we have our solute and our solvent. And you just want to remember, we've said this before, but your solute is whatever's smaller and your solvent is which is whatever's bigger. Typically, a lot of times what we'll deal with is our solvent will be water, but it doesn't have to be. So just keep that in mind that solutions don't have to be aqueous. So we do have some different types, and we kind of talked about this before, or I said this in the very beginning here. We think of things as a form of like the liquids, but keep in mind that you can have, air is definitely a solution. And we have a lot of solid solutions, which are what we call our alloys. And again, just common ones: brass, bronze, steel, sterling, silver, pewter. We're going to focus on the liquids because that's what we deal with most directly. But again, it can be all sorts of things. Excuse me, I'm trying to stay hydrated. We talked about intermolecular forces, and they do have a role. So you want to keep that in mind. So obviously, ones that are going to play a big role. The first one is going to be the ion dipole. Because that's going to affect anything that's ionic that's going to be dissolved in water. And then you want to keep in mind that we also have our London dispersion. And remember, London dispersion is everything we have. So London dispersion is going to come into play most importantly for nonpolar substances because they also have to be able to dissolve into things. They're not going to dissolve into water, but they are going to dissolve into things. And then what you basically do when you're thinking about this is you kind of think about what's going on here. So you think about how are the intermolecular forces affecting? And you say, what are my solute to solute? What are my solute to solvent? And what are my solvent to solvent? You get the solution when your solute to solvent is the most important. So if the solute's only interested in itself, or the solvent's only interested in itself, they're not really going to interact. What you need is good solute to solvent interactions, so a solution actually can form. This is just a picture showing you how salt dissolves in water. And you can see there is an attraction between the ions and the water. The ions are very positive and negative, and the water has that polarity to it. So what happens is those solute to solvent forces overcome the attractions of the solutes to solute, and they also overcome the attractions of the solvent to solvent. So because that happens, we get a solution. If that didn't happen, we wouldn't get a solution, salt would just sit there. And then this process is called solvation because you're actually making a solution. And then because this is particularly in water, we call this hydration. So you just have to make sure, how do solutions form, what makes something form, that kind of stuff. All right, the only other thing I want you to see here is just, these are two different, this is showing you kind of what it looks like once they form. So here's our sodium ion, and all these kind of red things around it are red and white things. These are water molecules. And what you can see is that the oxygen is the negative side, and it lines itself up with the positive sodium. So all these oxygens are negative, delta negative, they're kind of negative, and they're lining themselves up with the positive. And then on the other end, we have chlorine, which is negative, and then here we have delta positives, and they're lining themselves up. And then the last thing for this section I just want you to remember is it can be exo or endo. So it's not always the same. A lot of things are exothermic, but there are also endothermic ones. So you just want to keep that in mind, that just knowing a solution forms doesn't mean that you're exo or endo.